Alright, let's look at the practice exam 3, problem number 8. Let's find the sum of the series here. Alright, so first thing is there are actually two separate series going on here. So I'm going to just split them, split it into two series. First one is summation, n goes from 2 to infinity. Then you have a 3 over e to the n, right? And the second one is summation, right? N equals 2 to infinity. All right, I'm going to actually go ahead and factor it out. So you have a 2 over, if you factor this out, you have, let's see, n minus 1 times n plus 1, right? So we have that. Alright, and the first one is a geometric series, so all you really have to do is find the first element, which is a, then the r value, then a over 1 minus r gives you the sum. Alright, so here. Alright, so in order to find a, right, a is the first term. So in this case, you have to pay attention. This actually starts from 2. So if you plug in n equals 2 in this expression, you will get the 3 over e squared. So that will be the a value, or a1, same thing, right? Or actually, I should say a2. Alright, so you have a 3 over e to the e squared. Right, that's the a value, minus over 1 minus, right, r value. So r value is the number you multiply to go to the next term. So it's the ratio between two consecutive terms. And if you can't really see from here, then you can do the following. So in order to find r, all you have to do is let's do it here. R is going to be equal to, if you have a geometric series, it's a n plus 1 over a n, right? So a n plus 1, in this case, you have a 3 over e to the n plus 1. Right, divide by a n, so I take the reciprocal, so you have a e to the n over 3. Right, so you can cancel 3 on top and the 3 on the bottom. Then you have e to the n, and you have e to the n. Let's scratch that out. So you have e left over. So this is going to be 1 over e. Right, so it's going to be, our value is 1 over e. Right, so that will be the sum of the geometric series, which is this first one. Alright, second one is a telescoping series, so we need to find the partial sum. Right, before we do that, we actually have to do a partial fraction decomposition. So you have a 2 over, right, so you have n minus 1 times n plus 1. So we can decompose this into some constant a over n minus 1 plus some other constant b over n plus 1. Alright, and I'm going to put them all back together. So we have n minus 1 times n plus 1. And on top, you would have to multiply top by n plus 1. So a times n plus 1 plus b times n minus 1. Alright, so since we have the matched denominator here and here, alright, then we just have to match the numerator. So initially, numerator is 2. So this is going to be 2 as well for all n. Alright, so we get this equation. So we have a times n plus 1 plus b times n minus 1. Right, this is supposed to be equal to 2. Right, so let's try to find the a value. To find a value, we want to get rid of the b here. Easy way to get rid of that is set n equals 1. Right, so if you plug in 1, you see that 1 plus 1 is 2 plus a, so it's a 2a. Right, here 1 minus 1 is 0, so b goes away. And the right hand side is of course 2. So we can just simply divide through by 2 to get the a value. Right, a is equal to 1. Right, and if you want to find the b value, we can set the n equals negative 1. Right, and that way you have a negative 1 plus 1 is 0, and negative 1 minus 1 is negative 2b is equal to 2. Alright, and then we just have to divide through by negative 2 to get b is equal to negative 1. Alright, so we found this. So this is going to be equal to, a is 1, so it's a 1 over n minus 1. And b is negative 1, so I'm going to put the minus 1 over n plus 1. Alright, so let's compute the partial sum. So partial sum Sn is equal to, we just have to write down the first few terms and the last few terms. Alright, so it's going to start from 2. So it's a 1 over 2 minus 1, so it's going to be 1 over 1 minus, and 1 over, so this is going to be always a bigger, 2 larger than that number, so 1 over 3. Alright, next term would be 1 over 2 minus 1 over 4, and next term would be 1 over 3 minus 1 over 5. Maybe I'll write down one more, so it's going to be 1 over 4 minus 1 over 6. Alright, so you keep on doing that, and then maybe I'll do here. Maybe I'm going to continue on down here, so this is going to be plus. I'm going to write the last few, so it's going to be, let's see, I'm going to just go ahead and write the bunch of parentheses here. Right, and maybe I'm going to write 4 of them just to make sure that we can see the pattern here. Right, very last one is 1 over n minus 1 minus 1 over n plus 1. One before would be 1 over n minus 2 minus 1 over n. One before that would be 1 over n minus 3 minus 1 over n minus 1. And here 1 over n minus 4 minus 1 over n minus 2. Okay, I think that will be plenty. Alright, so let's cancel it. So cancel the bunch of terms here. So you have a negative 1/3 cancel with positive 1/3 there. Alright, and the negative 1/4 cancel with 1/4. Alright, you can't really see it, but the negative 1/5 cancel with the one next here, so it's going to be, there's going to be a positive 1/5, and so on. So you can actually cancel all these guys except for these first two. Alright, and here the same thing. We have, let's see, this guy cancel with that guy. Alright, but this one doesn't cancel, but this one has a cancel with that guy, and this guy will cancel with the one next here, which we don't see, and this guy will cancel somebody in there. Alright, so you can see that there are actually 2 terms in the beginning, and also 2 terms at the end. Actually, they stay. Alright, so I'm going to combine those 2 guys. Alright, so 1 plus 1/2 is 3 halves. and then you have to subtract 1 over n, and then subtract 1 over n plus 1. Alright, so this is Sn. So in order to find the infinite sum, all you have to do is take the limit as n approaches infinity of this guy, which is 3 over 2 minus 1 over n minus 1 over n plus 1. Alright, and this is a fairly easy limit to evaluate because this term goes to 0, right? And also this term goes to 0. You're gonna be left with 3 halves. Right. Here, I don't like having a lot of fraction inside the fraction. I'm gonna multiply top by e squared and also bottom by e squared. So what you end up getting would be, right? Alright, so you have e squared and e squared cancel out. So you just get 3 on top. Right? Then I'm going to just distribute e squared to the first guy. You get e squared. And we distribute e squared to the second guy. We end up getting negative minus e. Right? And plus, right, 3 halves is the limit there. So this is the infinite sum for the telescoping series. Alright, so therefore, this is the sum of the given series. Alright, that's it. I hope that this was clear.